welcome to Pre-Calculus. Today we're going to be doing a very brief introduction into conic sections, focusing on the circle and the ellipse. To begin with, hopefully you watched that video I posted where you could see an animation of the plane cutting through these cones, but here's kind of a summary of when you will end up with each of the different sections. So in a circle, the plane is parallel to the base of the cone, and that's when you're going to get a circle. When you start to angle that plane, if the angle is less than the angle between the side and the base of the cone, you're going to end up with an ellipse. If that angle is greater than the angle the side makes with the cone, or the side makes with the base, that's going to give you a hyperbola. And if the angle is parallel, or if the plane, is parallel to the base, that's when you're going to end up with a parabola. Let's take a look at the general equations for each one. For a circle, notice that we have a center given by x0, y0, and a radius of r. So the equation is x minus x0 quantity squared plus y minus y0 quantity squared equals the radius squared. With an ellipse, we start with the same general idea. However, in order to elongate each section, we are going to be multiplying or dividing each of those terms by a stretch factor. So A is our horizontal piece, and 2A would be the distance between the horizontal sort of maximums. B represents the vertical stretch, and so 2B is going to give you the distance between the vertical maximums. Okay, so that's kind of how that works, and we'll talk through that more when we look at the ellipse equations. The biggest difference you'll notice between the ellipse and the hyperbola equations is that for the hyperbola, we're subtracting the two terms instead of adding them. Making one a negative term is going to force this into a hyperbola shape rather than the ellipse shape. And depending on which term is negative is going to give you either hyperbolas that open left right or hyperbolas that open up and down. Finally, here's the equation for a parabola. You've seen several different versions of this equation. This one is the conic sections form of this, and we'll talk more about that when you get to that point. So let's take a look at a circle to begin with. So what we can do is we can use this information to help us find the equation from information or find information from the equation. So if we have a center at 4, -1 and a radius of 6, our equation, we have x minus x naught squared plus y minus y naught squared equals the radius squared. So plugging in the information from the center and the radius, simplifying, we get x minus 4 squared plus y plus 1 squared equals 36. And that would be the equation of that circle with a given center and radius. Now, in this next one, we have endpoints of our diameter. So we have an endpoint at 3, 5 and an endpoint at 3, 11. And that forms the diameter of our circle. So the center is going to be halfway in between. So to find halfway, we can average the coordinates. So if I take 11 plus 5 divided by 2, 16 divided by 2 would give me a y coordinate of 8. The x coordinates didn't change in this one, so they're just going to stay 3. So it means I have a center at 3, 8. the distance between the center and any one of the endpoints is going to be our radius. So in this case, our radius is 3. So then we can take this to our equation. So x minus 3 squared plus y minus 8 squared equals 3 squared, which is 9. We can also work backwards from this point. So if we have the equation, our goal is to figure out the center and the radius. So the radius squared is the value in our equation. So to find the radius, we want to take the square root. So in this case, my radius is 4. Then we want to figure out what values I'm subtracting in for the center. So x squared is x minus 0 squared, and y minus 5, that means that this would be 5. So we have a center at 0, 5, and a radius of 4. Okay, so same idea. To find our radius, we want to find the square root of 20, which will reduce, or to simplify, to 2 square roots of 5. And then we subtracted 3 and negative 7 for our center. All right, for our ellipse, we're going to make this our horizontal is major. So we want to find the equation of a central, or of an ellipse that has a center at negative 3, 5. The major axis, meaning the longer distance, is our horizontal. And our minor, the smaller distance, is our vertical. So in our equation, we need to figure out what each of those parts are. So A is 10 divided by 2, which is 5. B is 6 divided by 2, which is 3. So in our equation, we get x minus negative 3 squared divided by 5 squared plus y minus 5 squared divided by 3 squared equals 1. So this would be x plus 3 squared over 25 plus y minus 5 squared over 9 equals 1. All right, working the other direction to find the center and major axes. The center is going to be the value that's being added or subtracted to our squared terms. So in this case, our center is at 0, 0. The value under x squared is a squared. So a would be 10, and 2a would be 20, which is our major axis. B squared is 64. Taking the square root, b is 8. So 2b is 16, which would be the minor axes. Now, if you notice in this next example, we do not have the same form. It's not equal to 1. So the first thing we're going to have to do is divide everything by 100 so that we get to that same form we've been working with. So this becomes x squared over 25 plus y squared over 4 equals 1. Then we can identify our center. We can find a squared and b squared. So a is 5, 2a is 10, b is 2, and 2b is 4. Okay, so this is called the general form or general equation for a conic. And basically, we've multiplied everything out, we've combined like terms, and we've set it equal to 0, just like this would be the standard form for a quadratic. Same story, this is the standard form for a conic. And depending on the coefficients of these terms, that's going to help us to establish which type of conic we're looking at. And really the part that's important for us to pay attention to is the x squared and the y squared terms. If those two coefficients are equal, that means we have a circle. If they have the same signs, so if we multiplied them together they would be positive, we're going to end up with an ellipse. If one of them is missing, meaning that if I took a times c we get 0, then we would end up with a parabola. By the way, if they are both missing, then we would have a line. So it can't be both, it has to just be one. And finally, if a times c is less than 0, or the signs, they have different signs, that's the clue that we're going to have a parabola. So I've given you 4 equations down here, and let's see if we can match up which type of conic we're looking at. So in this first example, I notice that my x squared term is 4, and my y squared term is missing, so that means it's 0. So if one of them is a 0, that means you have a parabola. All right, let's look over here at the second example. My x term, or my x coefficient is a, my y squared coefficient is -1. Because they have different signs, that's going to be a hyperbola. All right, in this third example, I have a +2 and a +4. Since they are both have the same signs but are different, that's going to be our ellipse. And last but not least, if the x squared coefficient is the same as the y squared coefficient, then you get a circle. That should give you the big ideas for today. Please work through the independent practice. Ask if you have questions. Congratulations, this is our last new lesson for the semester, and just gives you a taste of what conics are and kind of how that equation of a circle and an ellipse work. Thanks for your hard work. I wish you guys the best. Good luck.